I handed out this conversion chart for you, and I kind of want to just point out a couple of things. In every chemistry class, every science class you ever take, you're going to get conversion factors. So they're all going to look different. The important thing is for you to be able to understand how to use the conversion factors, and that's what we're going to talk about today. You might notice that this one has the metric conversions up here too. It's just another way to look at it than the paper we got the other day. The ones that we're going to actually look at a little more today are this weight and mass, volume, length and distance, and then we will be using this paper all year long. Okay, so you want to make sure and put that maybe somewhere in the front of your notebook or somewhere in your folder where you definitely won't lose it. But we will be coming back to this paper as we move along. You might notice we've got liters and quarts, so like from that standard to metric conversions. Alright, so like I said, I want you to have this chemistry 1 worksheet up, and we're just going to start from the top. Okay? Alright. So you should have a page in your notebook open. Okay. I'm going to title my notes today Factor Label Method. I'm going to leave some space at the top so that I can write my steps, because at some point you might need to come back and write some steps down of how to go about the problems. And I'm going to start with number 1 on the page. Okay, so number 1 says, how many deciliters are there in 0.0083 milliliters? So the first step for the factor label method is to find the unit that you have. So write down your known value. So and what you want. What you want to get. So I'm looking at number 1 again. It says how many deciliters are in 0.0083 milliliters. So I have and I want to get to deciliters. And like I said, I will post this video on the lesson today. So alright, so the second step is to find conversion factors or conversions that could cancel what you have. Okay. Alright, so I am looking at my problem here, and I'm going from milliliters to deciliters. Now, we did this the other day. Remember we had this page, and we could go from milliliters right here to deciliters right here. Alright, so if we did that, we would have 1, 2, 3, 4 steps. So I would need to use a number that has 4 zeros and a 1 in front. I'm going to come back over here and I'm going to write that down, because we still need that skill. 4 zeros. For conversion factors, we have to think for a second. Okay. Which one is the big one and which one is the small one? Is milliliters smaller or is deciliters smaller? Milliliters are smaller. So it's going to take whatever your number from your steps, 10,000 in this case, 10,000 of the small one, 10,000 milliliters to equal 1 deciliter. Okay. So we're going to go through both ways, and that way you can see the difference. But let's just start with the conversion factor way. That way we're practicing what we just saw. So we're going to write down what we have. You're going to notice when we do these chemistry things, showing your work is a lot of being meticulous with your notes and with your writing down, showing that work. And then we're going to multiply by a conversion factor. If I want to get rid of milliliters, what's going to go on the bottom? Milliliters, right? Some of you are saying that. Little whisper voices. And milliliters. Because remember, if I divide milliliters by milliliters, then I'm going to get rid of them. So I can cancel those out. I know that my 10,000 is going to go with the milliliters because in the conversion they are together. So in the problem they have to stay together. I'm going to come up with the other part of my conversion. So that's 1 deciliter. Now, the other day, some of you were just moving the decimal point, and that is fine. That works. That's a good kind of cheat way to get that done. But when you are moving the decimal point, you are mathematically dividing by the number. So let's look at that in a calculator form just to kind of prove the point of what you are doing. Okay? So if I have my calculator here, hopefully you can see that. And if I go 0.0083 divided by 10,000, that's what I'm going to get. Oops, you can't see that. Alright, so let's go through that, what actually this problem was. We did 0.0083 times 1, which means it's itself. And then we had to divide by everything underneath. That's what that other video said. So we came up with this number. If I go to this and I just move the decimal point, am I going to come up with the same thing? Yeah, I am. So that works. Alright. So let's prove it. If we go, what do we say, 4 times? 1, 2, 3, 4. Alright, my number is going to be 1, 2, 3, 4. Same number. So you can do the metric to metric just like you've been doing them if you feel more comfortable with it. Or you can use a conversion. I don't care. As long as you get the right answer. That's what's important. Alright. So let's see where you're at. Show me a thumbs up if you're like, yeah, that kind of makes sense, and a thumbs down if you're like, nope, totally still lost. Okay. Alright, we don't have very many sums sideways, so we're kind of one or the other. Alright, let's do another one that's a little bit, a little bit less. I'm just going to do it the easy way, okay? So let's scoot down, and we'll do, let's do number 4. Okay? Pencil. Let's do number 4. Number 4 says 0.065 meters squared and is equivalent to how many centimeters squared. So this one is one that could potentially throw some people off as we're working through. This is still metric to metric, okay? But let's look at what we have to cancel when we're canceling our units. So, let's see. If I have, the next step, I wrote down what I know and what I need to get. Then I need to find a conversion. What is a conversion between meters and centimeters? So how many centimeters are in a meter? 100, I heard some people say. So 1 meter, remember your meter stick? Alright, we can use that conversion. So let's look. We're going to write down what we have. Alright, and then I'm going to use my conversion. What's going to go on the bottom? 1 meter or 100 centimeters? I heard some mumbling of a meter. 1 meter. Why? So it can cancel out. Now when I look at this meter, is one little m going to cancel out both of these m's? No. So I can cancel here and cancel the 2, but I still have an m. What's going to go on the top right here? $100. Okay. So looking at what I have, if I've canceled that, I still have meters, centimeters. So what do I need to do? I still need to cancel a meter, right? So what we're going to do is we're going to use that same conversion again. So now I can cancel this meter with that meter, and I've gotten rid of my meters squared. This will kind of come back later on as we do some more derived units, as we do some more formula stuff. So in this case, I'm going to multiply straight across. Okay. So I'm going to get 650. Now what is it when I do centimeters times centimeters? Because they're still part of the numbers. Centimeters squared, right? And then I gotta multiply straight across the bottom too. But in this case, what do I have? Well, you have 1 and 1, so 1 times 1 is 1, but did I get rid of my meters? Yeah, I canceled out my meters, so I don't have those anymore. So really, this should be an invisible one in my answer. Okay. So that's one of those tricky but not tricky. You have to really think. Like I said earlier, it's a thinker kind of lesson. Is your hand up? No. Okay. Alright. Alright, I tell you what, let's do one more example and then I'll have you try some on your own. I think we have time for that. Alright. Let's go to number 5. Are we ready? Some of you are still writing. I'll give you a second. Number 5 says determine the number of deciliters in 2.50 cups. So if I write down the known value, 2.50 cups, and I want to get to deciliters, well, I'm going to have to go to that conversion sheet. So I'm going to have to think, what do cups measure? Do they measure distance? Do they measure mass? Do they measure volume? cups measure volume, right? So we're going to come back to this conversion sheet that we had earlier. We go straight down to the middle. We have volume. So I've got to find cups because I need to cancel cups. Right, here's cups. But I don't have anything to go straight to deciliters, so this is going to be more than one step. So I could go cups to quarts, or no, I could go cups to pints right here. So I have to, then I could go pints to quarts, and quarts to gallons, and then gallons to liters, and then can I get liters to deciliters? Yeah, that's a lot of steps, but sometimes that's what we're going to do, what we just have to do. So what I like to do when I have a lot of these conversions I know I'm going to have to do, I like to write them down on my paper so that I don't miss any. Okay, and plus I have them. So we have our, on the paper we said we were going to use 2 cups equals 1 pint. So then we have to go from pints to something. So 2 pints, I'm just reading from that conversion sheet, equals 1 quart. 4 quarts equals 1 gallon. 1 gallon equals 3.78 liters. And then my problem wanted me to get to deciliters. So how many liters are in a deciliter? If you don't remember, you want to come back to your steps on your prefixes. If liters are here, deca is 1 step away. So a deciliter is 10 times as big as a liter. So for my conversion, I know that the liters are the smaller one. It's going to take 10 of the smaller one, 10 liters, to get to the deciliter. So I'm going to write that down. 10 liters equals 1 deciliter. Whew, that's a lot of conversions. So now we can write down the math. This step is just if it makes you feel like you know what you're doing. You don't have to have that one. I like to use it because it helps me to keep everything straight and organized. Okay, so I'm going to start with the number that I have, 2.50 cups. Okay, and I need to get rid of cups. So I know I had to start with this conversion. What's going to go on the bottom, 2 cups or 1 pint? Okay, I heard somebody say 2 cups, so my cups cancel. I'm going to come up with the other side, so I use 2 cups. I'm going to come up with the other side of that conversion, 1 pint. Alright, so now I need to go here. I want to get rid of pints. What's going to go on the bottom? 2 pints or 1 quart? 2 pints, right? So now I can say, okay, I canceled my pints, and I'm left with quarts. I came up with quarts. I'm going to say, all right, what's going to go on the bottom? 4 quarts or 1 gallon? 4 quarts, because I need to cancel my quarts. I always want to keep that organized. I'm going to come up with, so I use 4 quarts. I'm going to come up with the 1 gallon. Now I need to get rid of gallons. So what's going to go on the bottom? 1 gallon or 3.78 liters? 1 gallon. Okay, so I used my 1 gallon. I came up with the 1 liter, or 3.78 liters, I'm sorry. So my gallons canceled. What am I going to put on the bottom? 10 liters or 1 deciliter? 10 liters. So, in this problem, now we're dealing with kind of smaller numbers, so you could do this on paper in your head, but I like to use a calculator because I'll just confess right here. After all that thinking and all that processing of how am I going to cancel these, I don't want to make a silly math mistake. So, your choice in life. But I like to use my calculator. Okay, I'm going to pull that up here and type in my numbers. Make sure I got it. Yep. And so I'm going to go straight across the top. Okay, so what I'm going to put in here is 2.50. Okay, and really, your choice again, but I'm going to say times 1, times 1, times 1, times 3.78, times 1, and that gives me 9.45 deciliters because all the other units canceled. But then I have to go across the bottom. And once again, you could do this in your head, but I just like to check myself. So I'm going to go straight across the bottom. Okay, I'm going to say 2 times 2 times 4 times 1 times 10. That gives me 160. And I have to divide that number to get my full answer. So I'm going to say 9.45 divided by 160 equals 0.059. And we look back at what we started with. We had 3 numbers. We'll talk about significant digits coming up, but the most accurate answer would be 0.0591. I will not count it wrong for right now if you just have 0.59. Okay. Alright. Let's pause there for just a second. How many of you feel like this is making sense? You kind of get it? A thumbs up, thumbs down if you're like, nope, still lost in the world, and somewhere sideways if you feel that way. Okay, alright, we're starting to make sense of it. Alright.